So let's do a few examples, maybe 2 examples on continuity. Okay, so example. So let f of x be the following function. I'm going to define a function. x2 minus 9 over x minus 3 if x is smaller than 3. 9 if x is equal to 3, and sine of 6x minus 18 over x minus 3 if x is greater than 3. Okay, so this is the function, piecewise functions. Piecewise function that connects at x equals 3. Okay, the question is f continuous at x equals 3? And if not, classify the type of discontinuity. Okay, so when I say the type of discontinuity, I mean, is it a jump discontinuity, or is it a removable discontinuity, or is it an infinite discontinuity? We'll see. Okay, so do you remember the definition of continuity? Okay, so a function is continuous at a certain value or a certain point if the limit exists, so left and right must be the same, and it needs to be equal to the value of the function. Okay, so we're interested in x equals 3, so I'm going to see what happens if I approach 3 from the left, so using this function, and what happens if I approach 3 from the right, so using this function, and see if the limits match. If they match, means the limit exists already. Okay, and then we'll take it from there. So limit x approaches 3 from the left of f of x equals to limit x approaches 3 from the left. So which part of the function am I going to use? Left of 3, so this function here. x2 minus 9 over x minus 3. This is a limit we need to evaluate. We've done a lot of these. Okay, so we plug in 3 and we see that it's 0 over 0. So I factor x minus 3, x plus 3, and on the bottom, x minus 3. Cross out the x minus 3's. Plug in 3 inside, you get 6. Okay, the limit from the left is 6. Any questions? Okay. Limit from the right. F of x, so I'm going to use the function that's to the right of 3. So it's limit as x approaches 3 from the right of the sine of 6x minus 18 over x minus 3. Again, if you replace x by 3, you'll get sine of 0 over 0. Okay, so we need to recognize our sine x over x, right? Because we know that that's 1. So what I'm going to do is I'm going to go like this. Limit x approaches 3 from the right. Sine of, so here I could extract a 6 inside. So 6 times x minus 3 over x minus 3. Okay, so it would be perfect if there was a 6 here. If there was a 6 here, then I would have sine of 0 over 0, and what's inside the sign and what's in the denominator is the same thing. And that I would be able to say that it's 1. So I need to multiply here by 6, and of course, I will multiply the top by 6 as well. Okay, and now I know that this limit here will give you 1. So this is 6 also. You good with this? Okay, so now we know that the limit exists and it's equal to 6. So the limit as x approaches 3 of f of x is equal to 6. And so the first requirement for the function to be continuous at x equals 3 is already satisfied because the limit exists. What's the second requirement I need to check?
fa equals to fx.
Okay, so this limit has to equal to f of 3. Okay, so I'm going to ask myself, is limit as x approaches 3 of f of x, which is 6, is it equal to f of 3? Okay, that's what I need to ask myself. And so it seems not, because as you see, limit x approaches 3 of f of x is equal to 6, which is not equal to f of 3, which is 9. You get it? So here.
We can't see, sir.
Oh, sorry. Let's move on. Sorry. Okay, so this is where the problem is. Okay, it will, if in my function, instead of being, I'm just going to move up a bit, 2 seconds. There you go. If this here was a 6 instead of being a 9, the function would have been continuous. Okay, are you with me? You understand? So let me write down the conclusion here. Since the limit as x approaches 3 of f of x exists, but limit as x approaches 3 of f of x is not equal to f of 3, then f has a, so what type of discontinuity do we have here?
Removable discontinuity.
Very good. As a removable discontinuity at x equals 3. If I'm going to try to, just with the little space that I have here, show you what this is going to look like. Okay, so let's say this is 3, this is 6, and this is 9. And so my function is like this. Who cares? Who cares? Okay, but what's important is that there's a hole here and the dot is here at 9. That's the situation. You understand? Any questions? Okay, we don't have time for one more. Okay, we'll do it next class.